Ang pag-uusapan natin is the two major kinds of our passive filters. So when we say passive, gumagana yung ating circuit or typically or specifically our filter circuit. Gumagana siya without the use of power supplies, hindi siya nakadepende sa mga ganun. Halimbawa, ang op-amp, nakadepende yan sa external power supply, ganun. In this case, passive filters use passive components. So what are examples of passive components? There are three major types of passive components: the resistor, the capacitor, and inductor. So if you are not aware, these are the symbols of for schematic diagrams of each component. Ayan, okay. So ano yung two major types ng passive filters? One ay yung low pass filter and high pass filter. Okay, let's try to draw each graph of our filter circuit. Given na ito yung ating sabihin natin Cartesian. So our x-axis refers to the frequency, tas ito yung given na amplitudes. Okay, itong initial value is 0 and we are approaching to large frequencies which is denoted as infinity. Ayan. So itong gitna natin we considered as the cutoff frequency. Yan, kung saan siya nag-aalaw, parang ganun. Okay. Pag sabi nating low pass filter, yung mga low frequency ang inaalaw natin na dumaan sa circuit, which in this case zero frequencies are considered low frequencies. So sabihin natin, lagyan natin ng amplitude na ganyan. Ayan. Tapos yung infinite or large frequencies, they are tend to approaching to zero frequency. Ayan. Tapos connect mo siya. Ayan. Mayroon siyang parang rate na nagdi-decay. Di siya nag-off agad. Okay? Yeah, yan yung graph natin. Try din natin dun sa high pass filter. Ayan. Ito naman yung high pass filter natin. Okay, let's put some arrow. Ito rin 0 to infinity. Frequency pa rin. Okay. Kapag-pasensya nyo na ako naging blue. Okay, ang gitna ulit natin, yun yung cutoff frequency. So, high pass filter, pag sinabing high pass, high lang yung pinapas. High lang yung pinapadaan. O high frequency. So, may amplitude yung high frequency natin. At yung mga low frequency natin, mababa. 0. Ayan. Kaya ganyan. Ayan yung graph ng ating HPF or high pass frequency. Okay. Proceed tayo sa problems. Okay. Number 1. Given our transfer function h of s equals to 160 over 200 plus 2s. Determine the type of filter, the cutoff frequency, determine the gain, and lastly our bandwidth. Okay. Mali spelling ko. May di dyan. Okay. Let's try to solve. Okay. Katulad ng ginawa natin kanina, no? Yung S kasi, kino-consider natin as variable. And S is denoted as our frequency. Ayan. May ibang solving methods dito kung saan mayroong mayroong sinusundang transfer function model. Pero in this case, we are trying to solve it by substituting values dun sa S. Okay, so in this case, kino-consider natin yung S as variable. So, anong nangyayari sa transfer function kapag low frequencies ang nilalagay natin? Let's say 0. Ayan. 0. Okay. So, substitute natin. 160 over 200 plus 2 times 0 na. Naging ganyan. So, typically, naka-cancel to at ito yung natitira. 160 divided by 200. And this is actually 0.8. Ayan. 0.8. Ayan. May values na tayo nakuha. Nice. And yung isa natin kukunin is h of infinity. Kasi large frequencies yung kukunin natin. Ganun din. Kaso, kapag nagsasubstitute ka ng infinite, hindi ka pwedeng mag-direct substitution eh. To make it formal, we use the concepts of limit. Gawin natin S. 160 plus over 200 plus 2S. Ayan. So, alam natin, di ba, na ito, lagay ko sa gilid. Limit ng x approaches to infinity plus 1 over x. Anong sagot dito? Okay, let's say, if a number is divided by a large number, the quotient will be approaching to a lesser value. Paunti ng paunti kapag nagdi-divide ka sa malaking number, di ba? So, paunti ng paunti, pabawas ng pabawas, approaching sa 0. Ayan. So, in this case, we'll try to divide them by S. Di ba? Nyari, times mo by 1 over S, times mo rin itong baba ng 1 over S. Nagka-cancel naman yan lahat eh. We don't change any values at all. Okay, copy natin. Infinity 160 over S divided by 200 over S plus 2, diba? Na-cancel kasi S eh. So, magiging 0 to. And this to. When numerator is 0, the answer is simply 0 also. Ayun. So, ano yung sagot natin dito? Graph natin. Try natin i-graph. Itong x-axis yung frequency pa rin. Ito yung 0, infinity. And yung gitna natin ay cut-off frequency. Ayan. Gawin natin yellow. Okay. Sabi daw dito, kapag h ay 0, low frequency, nasa 0.8 siya. Ayan. 0.8. Tapos 0 naman sa infinite values. Ayan. Ayan siya. Malagay niyan yung graph niya. So, what kind of filter is this? Ito siya, oh. Ito siya, oh. Ito. So, our filter is LPF. Oh, nasagutan na natin yung unang tanong. LPF. Ano yung cutoff frequency? Dun muna tayo sa gain. Ano yung gain natin? Gain is simply the how much our initial value. So, from 0, 0.8 yung amplitude niya. Ito na yung gain natin mismo. Yun lang. 0.8. So, ano yung cutoff frequency? So, yung cutoff frequency, ayun yung sa denominator natin na wala siyang variable na S. Ayun. Ano lang, wala siyang S, gano'n. Tapos, parang pinaka-simplest term niya. Tulad nito, itong sa 160 over 200 plus 2S. That wala siyang coefficient, yung S. Ito. Kaso may coefficient siya eh. So, we simplify. 160 to 100 plus S. Ganyan siya. Ayan, makakancel mo pa ito, magiging 80. Ayan. Ito na yung ating cut-off frequency. Ayan. Ayan yung sagot natin. Okay, we can put 100 rad per second. And what is our bandwidth? Bandwidth is the same with our cut-off frequency na 100 din. So why? Kasi 'di ba from 0 to FC, ayan yung bandwidth natin. Bandwidth. So bandwidth is simply FC minus yung mababang natin bandwidth dito, which is zero frequency yan eh. Kaya ganyan. So our final answer is simply the cutoff frequency. Merong ibang intuition examples dyan, may ibang explanation, but this is the I think simplest and easiest way to understand. Okay, bigay tayo ng pangalawang problem. Bagong transfer function kung saan ano naman, sa halip na S, gawin natin ayan, complex. Okay, bagong variable, paano to? 10jw plus 5jw plus 20. In some cases, yung S naman eh, yung S sa Laplace transform is in the form of complex yan eh. Ganyan. JB, mga ganyan. Sometimes, the real part is denoted as 0, ganun. Pero, kaya ang notation niya. So, mga gantong notation can be rewritten as also as 10s 5s plus 20. Ayan. So far, we can simply rewrite this as that. Kasi minsan, pag gumamit ka ng J, ito, complex number, sometimes the method is using Fourier transform. And when S, Laplace yan, so magkaiba. However, the transformation domain is the same. We are transforming the function into the frequency itself. So, doon pa rin sa ginawa natin kanina. Kunin natin yung from 0. Ayan. From 0 naman. Dito naman, substitute natin. Okay. 10, 0, 5, 0 plus 20. Okay, 0 na agad yung taas. Alam natin yung sagot. Okay. From infinites naman. From infinite. Okay. Check natin kung ano yung problem natin kanina. Okay. From infinite or large frequency, lagyan natin ng limits pa rin. 10s 5s plus 20. So divide natin everything by 1 over s. Magiging 10 over 5 plus 20 over s, right? So may limits pa to, may limits. S approaches to infinity. Sorry kung ganyan nasulat ko. So magka-cancel to, magiging 0. Ang sagot natin is 10 over 5 or simply 2. Ayun. So plot natin, try natin i-plot tulad ng ginagawa natin kanina. Okay. From 0, pa tayo ng kulay. From 0 to large frequencies. Ayan. Sabi daw, pag large frequencies ang sagot natin, pag large frequency, meron tayong amplitude na 2, sabi. Tapos, pag 0, 0 rin. Ayan, ganyan siya. So, ano yung type ng circuit natin? Ito siya, ito, no? Which is HPF. Our filter is HPF. So, ano yung gain natin? Ito na yung gain. Ito na yung gain. Gain, ayan, kasi kung input mo 1, ganun, ano agad siya, amplitude niya agad nasa 2. Okay, ayun na yung gain niya mismo. Tapos ano yung ating frequency, cutoff frequency. Ito yung cutoff frequency. Cutoff frequency, katulad din ng ginawa natin kanina, yung constant term sa denominator. Okay, 10s over 5s plus 20. dapat walang coefficient tong S, wala. So divide natin, 10 S 5 S plus 4, yun. Ito na yung ano natin, ito na yung ating cutoff frequency. Okay, our cutoff frequency is 4 rad per second. And lastly, what is our bandwidth? Bandwidth is the same with 4 rad per second. Yung explanation din katulad kanina, no? Ano lang siya eh, same naman to ng gap, ito same siya. So yung bandwidth, ito yung bandwidth din to, ayan, and bandwidth din ito eh.